Okay, hello everyone. It's a great pleasure to be with you at React Miami 2026. My presentation today will be about brownfield applications and introduction of React Native to existing native applications. We'll talk about the concept, the challenges, and state-of-the-art tooling. Before we start, I'd like to quickly introduce myself. My name is Artur Morys-Magiera. I work as a senior React Native and AI engineer at CallStack in the R&D department, working on projects such as React Native Brownfield, of course, or React Native AI on-device runtime. I am also a PhD candidate in robotics and a fan of pointillist paintings. I like building things that connect science or advanced engineering with practice, which allows to build amazing tooling that eases work. And this is one of the reasons why I'm here with you today, because Brownfield, React Native Brownfield, is one of such things, an easy-to-use, feature-rich set of tools that do the complex and heavy lifting for you. But before we start, I would like to do a very quick survey. So if you would be so kind to lift your hand up if you're using React Native first. Very cool, very cool. I see the hands. And have you heard of Brownfield or used it? Please raise your hand up. OK, I see some hands, but less. That's good, because in IT, redundancy is in general good. But here it would make the speech boring. So let's get started. Brownfield itself as a concept means that you can embed any React Native application inside an existing native app, side by side, as it's shown in the figure. There is also a set of tools that materialize this concept, and it's also called React Native Brownfield. And the idea is that you can embed React Native apps side by side inside native applications with a tight integration that allows you to pass in data and interactions. And let's ask ourselves, before we delve into the details, why even Brownfield? Why would this be an important topic for us? So there are a few use cases. The most common one is migration of an existing native application to React Native tech stack. So you can consider a, let's say, moderately sized application that's shown on the diagram. And if you would like to migrate in your organization to the React Native tech stack, a single pass may not be feasible in most cases, especially for larger applications, because the process would consume a significant amount of time. That's the first thing. But also, if you would start such single process migration, it may turn out that as you are doing it, the work that the migrating team would have done at any point could become obsolete, could become redundant. Because of the ongoing development and maintenance of the existing native applications that should function during this process. It can take even months. So at best, it would create disturbances and redundancy in the development workflow. And moreover, the effects of this migration, either to the customers or even to internal stakeholders, couldn't be visible until you actually finish the migration, which may be long and may be problematic. So with Brownfield, you can perform a phased progressive migration procedure. You can select the, let's say, most important or most prioritized or maybe easiest pieces of the applications, either screens or components or maybe whole user flows, such as login, and then start with those and start gradually migrating your application to React Native. The ownership of the newly ported entities can be transitioned to the React Native team, while the native teams can still develop features or fixes to the remaining areas without colliding with the ongoing migration efforts. So this means you have full control over the process, ownership, and optionally, you can even do some advanced testing, such as A/B testing, to carefully roll out the migrated areas of your application. Finally, in the end, you will end up in a fully React Native project state, and you can sunset the Brownfield host application. This is the native application in favor of the new migrated app. And of course, the reasons I will just briefly touch because we probably should know at least some of them. So moving to React Native itself brings several benefits, such as OTA, over-the-air updates, iteration cycle, improved developer experience with hot reload, cross-platform applications, sharing between mobile and web, possibly if you have multiple flavors of the application, even between those. And the progressive migration allows you to do a seamless integration of the React Native and native pieces side by side, progressively at your pace, and allows you also to, which is very important, transition the skill sets of your developers, possibly native developers, to React Native during this process. Now let's take a look on the same chart, but from the low-level point of view, which is probably what a lot of us would be very interested in. So what must be present to start this process is naturally the React Native application. And this can be any type based on a framework such as Expo or not. There are no special restrictions on the application itself. It can be packaged as a library in general that you can then consume in your native application as if it would have been any kind of native library. And then you can simply embed this as a view, either one of the components or one of the screens in your application. The packaging process is a bit more complex because you need to package the JS runtime, the React Native parts, the Turbo modules, all native code, and any transitive dependencies of those native modules. A conceptually simple extension of this covers advanced use cases such as multi-flavor apps, for instance, where you have regionalized applications that share a common code, business logic, and maybe even components. And what we have just seen completes the example. What's presented is actually a brownfield, not just native application. So let's move on to the challenges. So with the possibilities, we also have the challenges. So how exactly do we build all that? I would like to present to you the technical aspects of the most commonly encountered in practice. The first one that probably already lingers on your minds is data exchange. So if you know some React Native internals, you may already know that there is a concept of the root view, which hosts view hierarchy in React Native, and it supports passing initial properties, but just once. So you can use this API to feed data from native to React Native, but only on startup. What if you need to dispatch dynamic events, for instance, perform an action or send telemetry to the native application? This could certainly be done with a native library backed by a Turbo module, but you need to build it. Such design could resemble the API we know from iframes, that is post message, which is an asynchronous bidirectional message lag. The other challenge is state coherence. So the mechanism I mentioned is good for dynamic events that may occur during interactions, but usually you will also maintain a, let's say, more persistent state, or maybe even multiple state stores that together are composed together form the state of your application. So in a coexisting setup of React Native and native, it is easy to imagine a piece of state that can be changed on actions both from the native and React Native worlds. So we need to maintain coherence. If we change the same variable from React Native, we should expect that native components on the native host side also reflect these changes. Theoretically, of course, we could use the message-based API that I just mentioned, but it has two drawbacks. Firstly, you would need to maintain the glue code that actually updates the state, and this is a place for vulnerabilities in the logic where you may forget about something or not handle all of the edge cases, all of the side effects. The other problem actually is that it induces extra redundant code that slows down your maintenance, complicates it. So a library that performs these coherent state updates would be a necessity. It should update the state coherently from both sides and allow you to define your store schemas and provide bindings or observability to the state values. Another challenge is purely technical, so it may not be as spectacular as the former ones from the practical standing point, but it's fundamental for React Native Brownfield. So since the library that you produce from the React Native application depends on React Native, how should the technicalities be handled? So should you embed everything in a single, let's say, fat AAR for Android? Should the React Native runtime, the native dependencies, transitive dependencies of those dependencies be included all together in the AAR? Or maybe the other way, you could simply only include the direct dependencies, the React Native runtime, Hermes, etc., and only add metadata for Gradle or Maven to pull in the other dependencies from the Maven central repository. So, well, it depends. You can go with both approaches, but sticking with the Android example, while packaging everything all together seems tempting because it's conceptually simpler, it yields a drawback because if your native application uses those dependencies, the same dependencies that may be transitive, for instance, to the React Native project, you may get duplicated artifact builders because the versions may be mismatching, and that's a problem. Even if you resolve those manually, you are risking breaking interdependency version compatibility on any third-party dependency. So with this in mind, the second approach, which, although it's a bit more complex, offers more flexibility and modularity, because you can always explicitly enforce specific versions of the common libraries in your native project that consumes the React Native app artifact. And an interesting fact is that even though this sounds like a straightforward way now because we considered all the risks, it actually is not, because the implementation of this on Android is not that easy. The best way to approach the problem is to build a Gradle plugin that will iterate all the dependencies, but there is more. It needs to filter out the tests, the transitive dependencies, and also especially handle the ones that should be baked into the archive, actually. For instance, the turbo modules, the ones that are auto-linked, and anything specific to Expo, and we will cover that in a second. The next challenge is navigation. So this is another aspect. If you have navigators both inside the React Native application and the native application, you would expect that probably the React Native part should also be able to invoke the navigators in native world. So this is why you would need to implement a turbo module to handle that. And finally, we get to the last challenge, which is Expo support, because Expo provides its own entry points and its own native APIs. They need special handling. For instance, the name of the JS entry point is fixed, so this is something that needs to change. You need to import Expo packages. And the hardest part is actually that Expo is also modular. It has many packages, and those packages are not available from the Maven central repository. They actually come into your project bundled inside node modules. The native artifacts are also pre-built and packaged with the tarbals. So Brownfield, a hypothetical Brownfield setup, should actually discover those modules that are needed and pack the native artifacts of Expo packages into the semi-fat, now semi-fat AAR. OK, cool. So we know everything. We iterated the problems and theoretical solutions, but, well, one thing pops out of this. We are not building that because it's just too much work. Nobody would like to do this. So what's state of the art? What's the approach to do this? And there's an answer. There is React Native Brownfield, which is a battle-proofed open source solution with over 7 years of history, created and maintained by Callstack. What is it? It's a complete ecosystem of utilities that make integration of React Native apps into native apps possible. And these tools address all these challenges that we have just iterated. The supported are Expo, vanilla React Native without a framework, and Rock. The platform supports Android, iOS, iPadOS, Android TV, and Apple TV OS. So let's take a look at how this package is structured. The core is named Brownfield, and it provides the necessities for packaging the library, wrapping your application or components. It also provides the things we mentioned in the initial challenges, that is data exchange. We can pass in the initial properties. We can do asynchronous data exchange over the post message-like API that we have iterated. And on the other hand, you have modular extensions to this that address the other challenges. For instance, there is @callstack/brownie that provides utilities for synchronized state management. You can define your own data store interfaces, then run the code gen, which generates the native glue code. And finally, you can consume the state on both sides, mutate it, listen to it from both sides. The same applies to navigation, which is in the package @callstack/browfield navigation, which allows you to invoke native navigation logic from the React Native world. And the cherry on top is the Brownfield Unified CLI, which ties all of these pieces together and allows you to build everything with one command, invoke all the necessary code gens, and this allows you to integrate Brownfield applications as easily as possible. The setup for Expo, by the way, is just adding one line of code because we ship an Expo config plugin, so you just add this plugin to the list in app.json, and that's it. And I hope you remember the slide that we talked through at the beginning of this talk, right? So let's revisit it with the React Native Brownfield library in mind. So the conceptually changing thing is to the left, because the packaging is automated by npx Brownfield, which you can invoke either to package for iOS or Android, and everything else will be handled automatically. This here is the line that I mentioned. This is the whole thing you have to do to integrate this with Expo. And to the right, you can see a demo application which integrates native views to the top in SwiftUI and React Native inside. And this slide, in turn, shows how you can integrate the React Native application into the native part. So as you can see, you can simply instantiate a new component in the SwiftUI view hierarchy, and that's it. The same applies, of course, to Android. There is Jetpack Compose that can consume this. Now let's talk about another problem we iterated. So asynchronous data exchange. The demo to the right shows you the package in action. So basically, you can dispatch asynchronous messages from the native side and the same from the React Native side. And you'll see the updates, the results in the React Native UI. So I think I don't have to iterate to get into the details more, because we all know the post message API. So the API is symmetrical. You can do the same from React Native and native. It allows you to, it basically behaves like an event emitter, so it allows you to publish and subscribe on both sides. And that would be it. Another package is called /brownie, so it allows you to do the coherent synchronized state updates on both sides that I mentioned. And you do this in the following manner. So first, you define an interface such as this one that stores the counter and user details in TypeScript, sorry. Then you run the code gen. And after running the code gen, you can consume this on the native side. So basically, you have to connect to the store, and then you can either subscribe to, or you can use the data binding API to do it both in SwiftUI and Jetpack Compose, and easily integrate the values with your components. And this is a demo of this mechanism. So you can see a counter variable that's being shown in React Native UI. And you can increment it both from React Native and native. And the same is displayed in somewhat smaller text to the top in the native UI. The other package is navigation. So it's also very similar to, conceptually to the Brownie library. You first define an interface in TypeScript that allows you to declare the native functions you would like to then invoke from React Native. Then run the code gen again. We know this step very well. And in the end, you can implement your class that is a delegate to this code gen glue code, and it can contain the actual implementation of the native actions that should be executed as React Native calls into those navigator actions. Now I would like to iterate the compatibility aspect. So we have a few versions, actually, of the Brownfield library, because it has somewhat a long history. So with version 3x, we support React Native versions from 0.81 through 0.85, the newest one, and Expo 54 and 55. At least these are the versions that we test and currently maintain tests for. Version 2x would support 0.81 and 0.82, and for older versions, you should use version 1x. Or, of course, if you are still using such LJC React Native versions. So how do I get started? Well, the answer is first you simply install the library Brownfield. Then you can integrate either with this single line of code in Expo, if you're using the CNG flow where Expo actually maintains your native application boilerplate code, and our plugin will automatically do all the integration at CNG phase. Or in other cases, you can follow the instructions, the precise, detailed instructions in our documentation that allow you to do exactly what the plugin does manually. And how do I use it? So you have all the options on the table, basically. You can run the app as you would normally do if this wasn't Brownfield, so standalone React Native application with Metro, etc. Or you can package it and run the native host application, both in development mode and in production. So in development mode, you will still have the hot reload from Metro. inside the native host app, or you can do it in production where the bundle is packaged with the native artifacts of your app library. So in summary, we have 3 packages: the core, the state, and navigation. Platform support is, as I said, Android, iOS, plus TVs. We have asynchronous data exchange inside the core, seamless integration to get all the React Native features, modular ARs for Android. We support Expo with Expo config plugin. And finally, we have 2 modular packages for navigation and state. And from here, before I finish, I would like to quickly give some thanks to all the OSS contributors to the library, especially to Hur Ally, who is our co-maintainer and the author of Brownie Android and navigation packages, to Sunju Kang, who brings support for hot updater to Brownfield, and for Michał Kudziak, who created this library 7 years ago. So I would like to thank you very much for your attention. And if you are interested in the project, please scan the QR code to be directed to the repository.